Start recording. Perfect. So you are going to, pardon me? It doesn't matter, just any kind of paper you want. We're just doing like a quick little review question. Oh, yeah. Okay, so see if you can remember how to do this, okay? And while you do that, I will take attendance. October 25th. Let's see, Cassie's here, Mackenzie's here. Caleb, Nathan, Alyssa, Tomas is not here. Evan's here, Connor, Zenny, Mila, Dario, James. Thank you. Izzy, Leon, Joy, Jessica, Eve, Sky, Isla. So if you don't have a piece of paper out, make sure you've got a piece of paper and try to answer this question. Write the symbol for a sodium 24 ion. And then you're going to, for that, or sorry, atom, not ion. And for that same atom, you're going to decide how many protons, neutrons, and electrons are there. Okay? And there's the symbol for sodium over on the left, like what it looks like on the periodic table. But feel free to use your own periodic table if you prefer. Yes? Isotope notation is where you have the symbol and you have a number up here and you have a number down here. That's an excellent question, okay? Haley's here, Nima's here. Reed is here, Kyan is here, Ella, Stephen, Matthew, Raina, and Jude. Hello, James. Okay. And don't be shy about asking your neighbor if you're not sure. And when you're done, you can just give me a little wave to let me know that you're as done as you're going to be. Okay. If you haven't managed to complete it because you've forgotten, that's okay. You can give me a little wave as well, and we'll go over it just to make sure that we start remembering. Okay. I will remind you of that when we all go over it together. Oh. Oh, it's the wrong one. Oh. Oh, the workbook? Yeah, no. All right, shall we give it a go together? What do we remember about this number that comes after the dash? That is the mass number. And so the mass number is equal to what? The protons plus the neutrons. So anytime you see the name and then a number, you're going to say, oh, that number is the protons plus the neutrons. So if we're now going to write the symbol for this, we're going to take our symbol, instead of X, we're going to have Na. And which number goes at the top and which number goes at the bottom? Actually, the proton number goes at the bottom, okay? And what's the other term we use for the proton number? The atomic number. And what goes at the very tippy top? Yes, the mass number. Tell your partner what the mass number is equal to. The number of neutrons and protons is the mass, yes. So that's our protons plus our neutrons. Why is electrons not in the mass number? They don't make a difference because they are so small. Okay? Yeah, 0.00001 or something like that, right? Or 2 or, yeah. Okay, so now we can say, how many protons do we have in sodium? We have 11 protons. How many neutrons do we have? We have 13 because we take 24 and we subtract 11. That is our mass number minus the protons, and that gives us 13. I know, I'm going all the way around. Totally. And what about the electrons? What do we know about the electrons in an atom? Do you guys know what the charge of an atom is? Atoms are neutral. That means their charge is equal to 0. So if you have $11 positive particles, protons, how many? Yes. Yeah, you would need to have 11 electrons. so that the positive and negative charges balance each other out, so they cancel one another out. So if I ask you about an atom, it's really easy to find the protons and the electrons, yes? Because they have to be the same. And I never did finish putting on the numbers on my symbol. Tell your partner what number goes at the top and what number goes at the bottom on our symbol. What number goes on the top? Mass number, so that's 24. And what number goes at the bottom? The atomic number, so that's 11. So this is the mass number, and this is the atomic number. I don't know for sure, I think the reason they write it in that order is that if you want to calculate the number of neutrons, very often when we subtract, we put one number over top of the other number. So if I rewrite this down here, and I take 24 and I subtract the 11, then I would get 13 neutrons. And I think that's the reason why the bigger number, the mass number, is on the top, so that you could just do, it's more visually like subtracting. That's just a guess. I don't know that for sure. Okay? So, how many electrons, how many protons, neutrons, and electrons in a calcium 40 atom? Try that one. You'll need your periodic table, look up calcium. Yeah, it's in the second column. Calcium's in the second column. Yes. We will talk about that in just a moment, once everybody's finished writing. All right, my friends, how do we know how many protons? There are 20 protons, right? Because that is our atomic number. And so there are 20 protons. How many electrons are there in an atom? A calcium-40 atom. Same number because atoms are neutral. And finally, how many neutrons do we have? 40 minus 20 is equal to 20. I would like you to give me the name of another possible isotope of calcium. So you're going to give the name of another possible isotope of calcium. Have you done that? Back row, who's chatting to each other, have you completed this question? Yeah? You did? Have you written its symbol in isotope notation? You wrote the name and the symbol in isotope notation? Okay, so that's why we're paying attention, right? Yeah, because we need to learn this. So could someone please give me another possible isotope of calcium? Connor. Calcium 41. Anyone have a different answer? Could you come up with another answer, Mackenzie? Calcium 42? 43. Yes, you could have calcium 43. There is actually a limit, and not all isotopes actually occur, okay? So it's possible that maybe there isn't a calcium 43, but if I ask you to give one that's possible, you would be allowed to like pick any number that's relatively close to 40, because 40 is the average. Now, do you see this number here? What is up with that number? Is that a mass number? That is not the mass number. That is the atomic mass. And please define to your partners what atomic mass is. Alrighty, what is atomic mass? It is the average mass of all the naturally occurring isotopes. Okay, so atomic mass is the average. That's why you have numbers like 0.1, right? Because you can't have a mass number where there's 0.1 because you'll never have 0.1 of a proton or 0.1 of a neutron. And mass number is where you add the protons and the neutrons. But when we take an average of all the masses of all the different isotopes, we can end up with a decimal number, okay? Pardon me? Yeah, you would do the percentage when you do that. So it was like that one we did with Tyler, where he had 20% was boron 10, right? Tyler DeWitt, that guy who does all the videos for us, okay? I just refer to him as Tyler because I spend a lot of my teaching time with him because he makes such great videos. I do, but I mean, you have to understand that I've been showing his videos for like 20 years, and so I really feel almost like he's an acquaintance. Like I have some DVDs in my basement that I do like Taibo to, like it's an exercise thing from like the late 1990s, and they're run by Billy Blanks, and so he's my friend Billy. So I have my friend Tyler and my friend Billy because I probably spend more time with either of them than I do with some of my friends from high school who I see maybe a couple times a year at most. So, you know, my friends on the internet who I've never met them, no. Although I had a student last year, one of my AP chemistry students, who sent Tyler a message on Instagram and he followed her back. And she was like, ah! Like there was much, you know, excitement around that. It was like, you know, our chemistry god friended her back, and I was like, okay, anyway. All right. So if you recall, and you don't have to write this down because it's not required for you to be able to do this, if you had 20% of the atoms, which were boron 10, and 80% of the atoms were boron 11, if you remember, we would take 0.2, which is 20%, times 10 AMU, atomic mass units, plus 0.8 times 11 atomic mass units, and you would get, I need a calculator for this, I cannot do this in my head. So 0.2 times 10 plus 0.8 times 11 equals 10.8 AMU. And if you look on your periodic table where it says boron, you'll see 10.8 at the bottom, which is the atomic number. No, unless you want to, it can be part of the enriched stuff. Do you know what I mean? Like it's something we, in grade 11 we do the math, here we don't do the math, but I'll put it as part of the enriched work, okay? Yeah. So if you're interested in just doing that math on a test, you can do it. If you're not, you can just be like, okay, I don't need to be able to do that. Not yet. Anyway, if you take chemistry 11, you definitely will do that, okay? What's that? You have to take a science, but you don't, it's not required for you to take chemistry 11. You can take any one of the grade 11 courses or more, right? It depends on what you're interested in. Yeah. Okay. Back to our isotope notation. If we had calcium 41, what is the isotope notation for calcium 41? What do we write? We write, what do we write for calcium? Ca. And where do we write the 41? Do we write the 41 at the top or at the bottom? At the top. What number goes at the bottom? The atomic mass? The atomic number, so that's going to be your 20. What's that? On the periodic table, the atomic number goes at the top. But on the isotope notation, the atomic number goes at the bottom. Okay? And I know it's a little confusing. Why couldn't they make it, consistent? I don't know. That's the way life is. A lot of the times it's because all of these notations are so old that they've just been used forever and ever, and no one's looked at them and gone, oh, let's make it better, because it's such standard things. Now, what if we wanted to draw the isotope notation for calcium 43? 43 would be at the top, 20 would be at the bottom. How many neutrons are in calcium 43? The neutrons, 43 minus 20 is 23 neutrons, right? You see how if you take that top number and subtract the bottom number, you get the number of neutrons. Top minus bottom equals neutrons. Okie dokie, has that been a fairly decent review of all of that stuff? We're feeling like it's more solid in our brains? All right. Now we are going to take a look with our friend Tyler, my friend Tyler, your friend Tyler, at ions. Because ions are something different. So far we have looked at atoms, which are neutral. Ions are not neutral, and Tyler will tell us how they work. So let's go to here. Actually, and in your book, this is on page, where is it? 84. Page 84. Okie dokie. Page 84.
Okay, what's an ion? People talk about ions all the time in chemistry. So what are they? Well, an ion is an atom or a group of atoms that have an electrical charge.
Okay, we'll just pause him for a moment until we can get it to full screen here, which apparently might take a minute. Oh boy.
Okay, that's all it is. Now, how does this happen? Well,
Inside atoms, there are two things that have an electrical charge.
Come on.
Protons that have a positive charge.
Pause. Full screen. Oh, how exciting. Okay, that was painful how long that took. Okay. This is page 84.
Okay, what's an ion? People talk about ions all the time in chemistry. So what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay,
That's all it is. Now, how does this happen?
What's an ion? Dario, what's an ion? Uh-oh, let's repeat it, okay? Atoms are neutral, but if we change them a little bit, they turn into ions. So they are an atom or a group of atoms with a charge. So normally when we say atom, we mean neutral atom. When we say ion, we mean we've taken that atom and we've changed it, so now it has a charge and we call it an ion.
Okay, what's an ion? People talk about ions all the time in chemistry. So what are they? Well, an ion is an atom or a group of atoms that have an electrical charge.
What's an ion? Yes. Yes. It's an ion, it's an atom or a group of atoms with an electrical charge. And in fact, on page 85, we can write that down, an ion let's get rid of phenolphthalein because we don't need that. Ion is an atom or a group of atoms with an electrical charge.
Okay, that's all it is. Now, how does this happen?
Well, inside atoms, there are two things that have an electrical charge.
What are the two things inside atoms that have an electrical charge? Whoa, what? Electrons and protons. Which is the one that does not have an electrical charge? Neutrons.
Protons that
Have a positive charge, and electrons that have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out.
So I'm concerned if people are chatting while this is going on, they're going to miss the information. Yeah? And I really don't want you to miss the information. So let's make sure we're listening.
That have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons.
So the charges balance out, and you don't have any total charge. But sometimes an atom can gain or lose electrons, so it gets more or fewer electrons and protons, and then the numbers don't balance out anymore.
So what is the atom doing? It can either gain or lose what kind of particle? Electrons. And then in losing an electron, it's going to lose some negative things, so it will become positive. If you gain an electron, you're going to become negative because you gain negative things.
And it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons.
Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn two things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral, so they're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around.
So what is its overall net charge? 0. So you can fill that in. It says net or overall charge. And you can fill in a 0 there.
Outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral.
You can fill in that word there. Neutral means no charge.
Okay? But here's what can happen to sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has 11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons.
Okay, so I chose a different electron to remove. I think because it was easier to do I think because he actually has maybe, I wanted them to look the same, I think. But you can see like a little dotted circle where I took the electron away, right? Yeah. So now you have 11 protons. What charge are protons? Positive. Now you have 10 electrons. What charge are electrons? Negative. Do you have more positive things or more negative things? You have more positive things. How many more? 1. So what's going to be the overall charge of this thing? 1 plus 1.
So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So
this thing now is going to have a charge of plus 1, one more positive charge, negative charge. And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge, whereas this, when I'm talking about a neutral atom, I'll probably just write Na.
Okay, so you can write down the symbols in the boxes where it says symbol. When you have the neutral atom, the symbol is Na. When we have the ion, do you remember how we have things in our isotope notation? We had our mass number up here. We had our atomic number down here. And that leaves the right-hand side empty, so we could put our charge up there if we need one. Okay? If it has no charge, we just leave that corner blank. Okay? So if I write Na, this has a charge of 0. Okay, and we leave this area blank.
So Na plus here is an example of an ion. It's an atom that has a charge, and
it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom. I'm sorry, an ion, what we call any ion that has a positive charge.
So cation is the name of a positive ion. And I'll throw my pen on the floor. That's exciting. And do you know what's in the middle of the word cation? A plus sign. Look at that. Cations are positive. There's another way to remember it though, and I actually like this one a little bit better because I get to draw like a little picture. What's that? It's a cat. What does it have? Pause. So cations are positive. Oh, cute, right? So between these two, between the fact that there's got a big plus sign in the middle of it, and the cats have pause, you will always be able to remember that cations are positive. Oh, yeah. Honestly, the first time people read it, if they haven't heard it pronounced, usually it comes out Cation or Cation or something like that, or Caution or something. Yeah, you wouldn't think it's cation, but it is. Okay.
Okay, let me show you another example.
Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside. So we have the same number of protons and electrons, which means that the total charges balance out, plus and minus balance out. So I have a net charge of 0, and I...
Okay, so you can fill that in. All right, we have 8 protons in oxygen. We have 8 electrons in oxygen. So what is the net charge? 0. Is everybody filling this in? I see some people whose pencils are not moving. You already put it in? Excellent. Okay.
I can say that my oxygen atom is neutral. It has no net charge. But
Oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons.
Okay, so how many electrons does oxygen like to gain? 2. And later on in this unit, we'll discover why. For now, just believe me, okay? It likes to gain 2 electrons. And you can see there's 2 extra electrons on our atom there. So now instead of having 8 electrons, how many will it have? 10.
And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, now it has 10 electrons instead of 8, which it had before.
So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive.
So what is going to be the overall charge of this new ion? -2, because we've got 2 more negative things than positive things.
I've got 2 more electrons and protons. So
that means that my total net charge is going to be 2 minus. I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O.
One thing I want you to notice, we don't usually write O minus 2. We write O2 minus. But because you guys are in grade 9, if you write -2 instead of 2 minus, nobody's going to get upset with you. Okay? So whether you write, it's got a -2, -2, or whether you write 2 minus, either way would be okay for grade 9. Okay?
This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion.
So we have cation for positive ions, and we have anion for negative ions. So we could have a negative ion. That's one way to remember it. But I'm hearing the word onion because it does look a lot like onion. This is how I always remembered it when I was in school. What do onions make you do? Cry. And that could be negative. Sometimes crying is healthy, but the kind that comes from onions is usually just a pain, right? So that's negative, okay? So, pardon me? It's helpful for that? Okay. So maybe you'll remember it the other way because this would not work for you. But anyway, however you remember it, anions are negative. So we have cations, which are positive. We have anions, which are negative. Are we ready to move on? Or do we need another minute? People are still writing. We need another minute. Good. Okay.
Has more electrons than protons.
Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge. Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion. But if something is an ion, it can be either a cation, which is what we call a positive ion, or it can be an anion, which is a negative ion. Here's a way that I used to remember this, okay? Anion, I think of this as standing for a negative ion, okay? And then cation, you can remember this, it's really cheesy. You can remember this because cats have pos, and a cation is positive. All right, you'll never forget it. I swear, you'll never forget it. Okay, there's one more thing that I want to mention. I've said that an ion is an atom or a group of atoms with a charge. I haven't said anything yet about the group of atoms. So more than one atom can come together, they can stick together and form a group or a clump, and then that whole clump of atoms has a charge. When this happens, we call it a polyatomic ion, a group of atoms that have a charge. Poly means many, and atomic, you have many atoms together that form an ion.
Okay, so that is the last word on this page. and that is polyatomic ion. Do you guys know the meaning of the prefix poly? Poly means many. Okay, poly means many. So if you are polyatomic, what do you have? Many atoms. Polyatomic, many atoms. What's that? Oh, yeah. Yeah, it does look kind of weird, doesn't it? Anyway, polyatomic ion. It's a group of atoms that has a charge. And we'll look at those in more depth in our next unit.
I'll talk about polyatomic ions in future videos, so you want to check those out if you need to learn more about polyatomics.
Anyway, just to review what we've learned. We learned that an ion is an atom or a group of atoms that have a charge, and something gets a charge when the number of protons and electrons don't balance out. You have more protons than electrons, you'll have an ion with a positive charge, you call it a cation. You have more electrons than protons, you have an ion with a negative charge, and you call that an anion.
We are going to take a 5-minute brain break, and then we're going to do page 86 and 87, okay? 5-minute brain break. So if you need to get a drink of water, if you need to go to the washroom, if you need to go walk up and down the stairs a couple times, if you want to do some stretches with me, I'll be up here doing some stretches. Or maybe not, I don't know. 5-minute brain break. But make sure you're not making noise in the hallway or bothering other classes. Otherwise, we'll never do this again. Oh, really? Yeah. Yeah, I hear fluorine a lot today. Yeah. That is quite a lot. Oh, the atmospheric river, yeah. Oh my. Yeah. There's a lot of water in the atmosphere. Yeah. Well, to be honest, we don't usually have that much rain here. I mean, we have lots of rain, but that was unusual. Yeah, that like 1 to 2 days where it was dumping on it. Yeah. Like constant dumping. Yeah. I think it was some days that school was canceled. Yeah. Yeah. I try to fit it into my week at least 3 or 4 times. I try to fit it in my weekend. It doesn't fit still. I know, it's so hard to like carve out time for these things. So hard. I've given up doing anything. Like I don't have hobbies anymore. I just like, you know, I'm either goofing off because my brain needs it right, or I'm exercising. And those are kind of like my two main things that I do, and I don't have time for any other hobbies or anything like that because I'm either just goofing off, reading a book, watching something, playing a video game, or I'm exercising. The rest of it is just laundry and dinner and, you know, marking and making workbooks. Yep. It really does. Okay. So this is 2.5b. All right, we are on page 86. So if you still have your phone out, you'll want your phone to go away. Alrighty. Yes, we are. I'm just going to start though because I said 5 minutes and it's been 5 minutes and I don't have time for this nonsense of 5 minutes being 10 minutes and I can't deal with it. So if they miss it, then they'll just have to watch the video later. Okay, so nature favors the most stable state. So if I have this pen, is this the most stable state for the pen? No. No, because if I let it go, what does it do? It falls to its more stable position, which is on the floor. Okay, because gravity pulls it down. Okay, so nature will on its own have things go from being less stable to being more stable. In order for things to become more unstable, you actually have to put energy in. You need to say, oh, if I want this pen to become less stable, I need to actually lift the pen up. Yes? So, please don't come back late from a 5-minute break, okay? And I'll be saying that a few times as people come back. Please don't come back late from a 5-minute break, okay? Please don't come back late from a 5-minute break. You will have missed things. When a system is stable, it just tends to stay there, right? If I've got the bricks piled up like this, are they going anywhere? No, but if I have them in an unstable position, you can see what are they probably going to do? They're probably going to fall down. Yeah. Now there's another way of saying stable and unstable, and that's to refer to their potential energy. Have you guys heard of the word potential energy before? Yes? Do we know what potential energy is? Try to describe it to your partner. If you are unable, don't worry, we will define it in a moment. Okay? Okay, potential energy, if you don't know yet, is stored energy. So This pen, when it's up high, it contains some stored energy. It is at a high potential energy state. And when it goes to the lower potential energy state, I want you to listen. Did you hear how energy was released? Sound energy was released. So that energy, that potential energy that was lost, we went from high potential to low potential energy. So we have less potential energy than before. That energy doesn't just go away, it comes out as sound energy. Also, have you ever warmed up yourself by, like, slapping yourself a little bit or rubbing or whatever? Okay, it makes the molecules in your hand move faster, and that's what warms you up. So the pen will actually get slightly warmer when it hits the ground because the molecules will be moving faster because of the impact. Okay? You don't really need to understand all the ins and outs of that. You'll be doing lots of potential and kinetic energy in grade 10. Potential energy is stored energy. The other kind of energy, and I'll just write it down, but we're not going to be spending a lot of time on it in grade 9, is kinetic energy. Do you guys know what kinetic energy is? It is the energy of movement. Okay? Kinetic energy is the energy of movement. But like I said, we're mostly going to be focused on high potential energy and low potential energy states. Nature loves to be at low potential energy. So if you put a ball at the top of the hill, will it spontaneously roll down the hill? Well, if it's just perched there and you kind of let it go, if it's not perfectly balanced, it will spontaneously roll down the hill. Can you have a ball spontaneously roll up the hill just all by itself? No. So low potential and we're going to call that low PE because writing potential energy every time takes way too much time. PE is much easier to write than potential energy. So over on our other side, we have high potential energy. This is unstable. Low potential energy is stable. You're going to hear these words a lot. They're super important in both chemistry and physics. And in fact, if you get into biology, like if you really dig deep into the biology, it's also important in biology as well, but not sort of at the more surface level stuff that we do in grade 11 and 12, okay? Now, let's see what you remember. An ion is an atom or a group of atoms with a net or overall charge. In a neutral atom, the number of protons and electrons are equal, or the same if you want to. So if you don't have a pencil in your hand, or if you see your neighbor doesn't have a pencil in their hand, give them a nudge. Make sure you're writing this down. Okay? So we have an ion, group of atoms or atom or group of atoms with a charge. In a neutral atom, the protons and electrons are equal. What can you say about the protons and electrons in an ion? They are unequal. What charge do protons have? Positive. What charge do electrons have? Negative. And if the number of protons and electrons in an atom is not equal, then the atom will have either an overall positive or a negative charge. Okay, and if we have an overall positive or negative charge, what do we call this? This is an ion. Why do atoms form ions? Well, it turns out, do you guys remember the term shell for an atom? Okay, in the Bohr model, we have the various shells. It turns out that a filled outer shell is very stable. Okay, pardon me? I think I might have caught that, but I didn't understand all the words, so I didn't quite catch it all. But okay, atoms will gain or lose electrons in order to have this stable filled arrangement. Here's a new vocab word. The outer shell is called the valence shell. Valence. You'll hear that word a lot. Okay. Now you can imagine if we have an atom and its outer shell contains 1, 2, 3, 4, 5 electrons. Is this outer shell closer to full or is it closer to empty? I'm just going to draw in boxes for the empty bits. Is it closer to full or closer to empty? Closer to full, okay? Closer to full. So what's going to happen is if you are closer to being full, we are on page 87. If we are closer to full, then what do you think that atom is going to do? Is it going to gain electrons to get a full shell, or is it going to lose electrons to get a full shell? It's going to gain, okay? So atoms with 5 or more valence electrons, they are all nonmetals. So what that means is that nonmetals will tend to gain electrons to have that full shell. When an anion is formed, something happens to the name. The ending of the name changes to "ide." Okay, so we have a fluorine atom, and we're going to go right till the end today, but you won't have any homework. How does that sound? Okay? So we have a fluorine atom, and fluorine has an atomic number of 9. So how many protons in fluorine? 9. How many electrons in a fluorine atom? 9, because remember, an atom is, what charge is an atom? Neutral. So if we put in our electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll notice it's a slightly different order than what we usually fill them in, but that's okay. We have an empty space in that outer shell. The outer shell would like to have 8 electrons. The outer shell wants to be the outer shell. So 1, 2, 3, 4, 5, 6, 7 in the outer shell. The other 2 are on the inner shell. Okay? The outer shell wants to be full. How many is full for shell number 2? Eight electrons. So what's going to happen is a little electron is going to zoom into that empty space there. And now instead of having 9 electrons, now it has 1 more electron. And so you have 9 positives and 10 negatives, which gives you an overall -1 charge. And we change that name then to, instead of fluorine, it is now fluoride. Enjoy a night with no science homework. I know it's rare. Woohoo! So I've recorded the whole lesson. So I don't know how much use that is, but I can also talk with Ms. Wu and Ms. Bellier, who are down in the Learning Center, and just like talk with them about what we've done. Yeah. Yeah. Perfect.